Okay, yeah, so the derivative of tangent is secant squared. So the derivative of tangent x is secant squared x. And then what happens to the 2? What's the derivative of 2? Yep, so the derivative of 2 is just 0. So the g prime is just our secant squared. So I can just throw the secant squared x in up there. Okay, so we kind of worked on that piece. Now we have to take care of all the parts with f. I'm just going to make a little bit of room here. So can we handle, how do we do f? So if we take a look at f1 prime, what's the derivative of e to the x? So I'm over here now. So if I look at f1 prime, I'm working on the derivative of e to the x, which is its own derivative. So I can actually put that in both places. And then I copy down g1. And what's the derivative of g1? What's the derivative of sine? Derivative of sine is going to be a positive cosine of x. Yeah, so we're going to have an e to the x plus e to the x cosine x. So that was f prime. Okay, so f prime then gets replaced with this bit. And I need to make sure I have my parentheses going on here. And f gets replaced with this part. Do we see how we have a kind of a road map for us here? Do you have questions about the way that I've done this? I'm trying to read to the chat window and see if there's any people who agree and or disagree. Yeah, so somebody put in the chat window thought the derivative of e to the x would be natural log of e times e to the x. You are absolutely right. What is the natural log of e? So the natural log function and e to the x function undo each other. Yeah. So no, you're totally right on that. We just never write that anymore because natural log of e is 1. So we're not too worried about it. Cool. So hopefully it's like, yeah, that's a little intimidating, but if you pick the rule that is all inclusive, it gives you a roadmap. And so you write down the structure. Oh, I need f prime g, f g prime, g squared with the sum and the difference quotient, the subtraction and the division. And then you can go to town filling in the pieces. And then each piece is hopefully a little more manageable. Okay, and then Mariana, was this a derivative? I'm assuming this is a derivative question here. I didn't actually have time to bring up the Desmos window. So here's another one for us to try. And again, I think the quotient rule is the all-inclusive rule where we would want to start. And so we could look at the derivative of the top, so f prime g, or if you're doing low d high, then you're going to have your first two terms switched. So the derivative of the top is going to have a product rule in it. So that's looking a little intimidating. So maybe I'll come down here and I'll say the top is x squared sine x minus 0.5x squared. So then when I take the derivative of just the top, I get to worry about the product rule here. And so the derivative of x squared is 2x, copy down the sine, plus copy down the x squared, and then the derivative of sine is cosine. And then I have to worry about the derivative of this last bit here, which is 0.5 times 2x. So that would just be x. So what questions do you have on the derivative of the top? And then the denominator is sine x times cosine. So we have another product rule. Yeah, so part of the struggle with these kind of problems is remembering to like, oh, wait, this is a product. I have to do the product rule. I think my dog's hearing things. So what would we get for the derivative of the denominator? Okay, so we would take the derivative of the first, so the derivative of sine is cosine, and then we're going to just copy down the second function. Then we do a plus sign and we copy down the first function, and then we multiply by the derivative of the second function. And the derivative of cosine is a minus sign. And this is one place where simplification is kind of nice because it's not that big of a deal. You get cosine squared x minus sine squared x. Okay. So yeah, watch for the derivative there. So sine is going to derived, not derived. Cosine will be not derived, derived. Okay, so now I think we're ready to put this all together. And so we would have low d high, if you want to do it that way, or the derivative of the top times like f prime g, whatever you're comfortable with. This part, the order doesn't matter. So f prime I could copy down from here. So we have 2x sine x plus x squared cosine x minus x. That's all just f prime. Then g is the sine x cosine x. So minus, and then f x squared sine x minus 0.5x squared. G prime, I'm out of room. We'll just do a little bit of creative manipulation here. Okay, so then G prime was cosine squared x minus sine squared x. Draw the line and square below, all over sine x cosine x quantity squared. All right, welcome back to the big room. I just want to make sure we're all on the same page. Additionally, if you're having tech issues, please email me and we'll see if we can work something else out. If this sort of thing is working for you, definitely let me know though. So just want to make sure we're all on the same page with the chain rule. I think you all got the message that I sent, but just to be painfully obvious, since that's a good theme for the class, I like to think about the inside function as stuff. So I would actually think about this as I take the derivative and then I plug in stuff and then I multiply by stuff prime. That's another, it's a silly way to think about it, but that's kind of the way I think about it. It's f prime of stuff times stuff prime. And we have the exact same notation down here, or the exact same meaning, just with Leibniz notation. So make sure you memorize the chain rule and understand that. Okay. Want to point out this type of question makes you understand that to do, for example, 18, you're going to write out the chain rule. So you do G prime of f times f prime. This notation here, this bar, and then x equals 4, that means evaluated when x is 4. So you're going to write out the derivative and then plug in 4 for all the x's. And then you're going to have to use the graph to get the information. So if you need f of 4, you go to 4 and you pull off the f value. If you need f prime of 4, you're going to use the slope of the function. So you could do rise over run to get the slope. So when we write arcsine or arctan, we are talking about the inverse trig function. So another way to do inverse notation is to use this -1 exponent. So make sure you're clear on what -1 notation means. This means inverse function. So sine takes in an angle and spits out a ratio. Inverse functions take in a ratio and return an angle. So just kind of a quick inverse trig review. If you've got to go, totally go. I'm going to take a few minutes to kind of wrap up a few things here. So yes, I totally understand we are beyond time, but make sure you look up these formulas to finish off this lesson. So I want to make sure that everyone gets these down. And of course, I don't have this one memorized off the top of my head for some ridiculous reason, and I'm worried this is going to be broken here. So we're just adding to the list of formulas that you need to memorize in terms of derivatives. So here's 3 new derivatives in addition to the chain rule. Make sure you practice, practice, practice. Otherwise, let me know what questions you have. Let me do slide 14 and then we'll do slide 16 real quick here. So the derivative with respect to theta of sine 3 pi theta plus cosine of 3 pi theta over theta. We're going to do the outside function, take the derivative, we get cosine. We copy down the stuff verbatim, don't even have to think. Then we multiply by the derivative of stuff. So the derivative of 3 pi theta is the same thing as like, what's the derivative of 5x? It's just a number in front, right? Okay. And then here we need to do the quotient rule. So we're going to have a theta squared in the denominator, f prime g minus f g prime on the top. So f prime, start with the cosine. Derivative of cosine is minus sine. So starting with the derivative of cosine, copy down the stuff, just copy it down, 3 pi theta, and then multiply by the derivative, which is just going to be 3 pi. So that's f prime multiplied by g minus f times g prime. And the derivative of theta with respect to theta is just 1. So Mariana, let me know if you have questions on that, if that's okay. And then the other piece is the derivative with respect to t of t plus 2 cubed times secant cubed 2t. And then this one's going to be evaluated when t is equal to 0. So yes, I would start with the product rule because it's the all-inclusive rule. I see this multiplication kind of as the big thing. We have one piece here and one piece here. And then inside each piece, we have to do the chain rule. So I would start with the product rule on this one. And so the derivative of the first one is now when I'm going to do the chain rule. And if you want, you can write it out in steps like this. So you have the derivative of the first times the second plus the first times the derivative of the second. This one's a little nasty because it's actually a triple chain there, isn't it? You got a lot going on. So that's kind of the structure I would use. And then when I did the derivative here, I'd have 3, copy down stuff. So the outside function is stuff cubed. So that's 3 stuff squared. Multiply by stuff prime, which is just 1 in this case. Copy down this guy. Copy down this piece. We already worked on that. Now the derivative here, I have an inside and an inside and an outside. So the outermost function is stuff cubed. So the outermost function is going to be 3 times stuff squared. Then the next layer is secant. And the final layer on the inside is 2t. Well, the derivative of secant is, this one's weird, because it's secant tangent. And then I just copy down the 2t, and then I multiply by the derivative. That one's nasty. That one's really nasty to throw in on a first day. So if you don't get this one, I get it. Like that's kind of a bear to throw in on the first day. And then you would just plug in 0 for all your t values. Slide 17. This is just asking us, do we want to probably think about this in notation? This says, what is the derivative of f when x is equal to 4? So what is derivative of f when x equals 4? Just trying to translate that into kind of English there. What do we mean? So I would go to the function here. I would take a look at 4. I would see what the function is doing there. And then I would interpret derivative of f as slope. So another way to think about it is, what is the slope of f when x is equal to 4? That's another way to ask that question. So does that help you understand what the question is asking?
Yeah, so we just like rewrite the equation as a word.
I would just come up here and say it looks like the function goes down 1 and over 4. And so the slope is -1/4.